voice on this though. When you listen,
you can hear the voice. It's just
my voice.
Yeah, the video didn't.
But you couldn't hear any sound at all from the video, or just it was muffled?
No, it played for like 2 seconds. You can just search it on YouTube.
I will. I'll get the videos for you, but I just find it frustrating because I thought I had this thing licked, like where I had it working well.
It might be YouTube automatically blocking the sound because it's recognizing that it's another video, or it could just be that it's not recording the computer.
It's probably the second one because it worked for a couple seconds and then it cuts out. So that's probably what it is. That was part of your solubility homework.
So we're supposed to do it?
Wait, what?
Yep. All right. Beer-Lambert law. It has nothing to do with beer, by the way. Not that any of you should have consumed that. And it tastes nasty anyway, so my opinion. All right. Beer-Lambert law. It should be at 3.13. Are you there? Everybody with me? This is the last section. Yeah. We're almost done with Unit 3 on the 31st. That's why everything hard deadline is the 31st.
So what are we going to do for like 9 days?
You're going to be gone for part of them.
Lab. Yeah.
You're doing the lab, you're doing a review, and then you're gone. And then when you come back to a test. Or a review and then a test. All right. Beer-Lambert law. One way that you can measure the concentration of a solution is by shining a light through it and seeing how much light comes out on the other side. Okay. Now this only works for pigmented solutions. So something that has a pigment in it. Okay. Because it's going to absorb some of that light and then you're going to detect what's on the other side. Things that are more concentrated will have less light coming out the other side because more of that light will have been absorbed. Okay. So the more concentrated the solution, the less light gets through. You can use that then to determine the molarity. So what you're going to be doing with your lab is you're going to be making set molarities. Like, you know that mine is starting out, the stuff that you're starting out with is 0.2, and you're going to dilute that down several times and see how much light gets through. And then you're going to take an unknown, which we're going to create either today or tomorrow or Monday, and you're going to use that scale that you've created using the known values to try to figure out where it's going to get placed in there. Okay. Now, you are going to be working with my vernier spectrophotometer things, okay, on the Logger Pro program. It does not automatically save for you. This is a multi-day experiment. You need to make sure that you're on the same computer and that you're saving your files, okay? Because that's not something that's necessarily intuitive to all of you, because Google does that for you most of the time. So you're used to Google just taking care of it. This is old school. You've got to go in and go file, save, okay? There have been many tears shed over the fact that people didn't go file, save. You're also going to keep your cuvettes until the end. That way, if you do screw it up, it's a pretty quick way to get back to where you were at, okay? And screw-ups happen. All right. Molarity then, you know what that is. We've got moles divided by volume of solution. So I created the solution back right behind Nicholas and Abby there. That is a 0.2 molar solution of copper nitrate. Okay. And then you're going to figure out today how you're going to dilute that down. Once you figure out how you're going to dilute it down and what quantities you're going to have, you're going to bring that to me. And then I am going to okay it and send you on your way. All right. Nicholas and Jacob, you're gonna need some graduated cylinders. Can you get out a 10 mil graduated cylinder for each station? I forgot to add that on there. 7 stations. All right. So you should know how to do this math for getting this diluted down. You're going to use this formula, M1V1 equals M2V2. All right. This number right here will stay constant. That is going to be 0.2, and you're solving for V1. This will be 25, and then this is going to vary depending on the molarity that you want to make. So if you want to make a 1.5 molarity, then you're just going to change, multiply and then divide by 0.2. And that'll tell you how many milliliters of this stuff you got to add in. And then what do you do with the rest of the stuff? How do you get to 25 mils? Water. Yep, you're going to add water until the meniscus reaches the etch line. Okay? And then for each different molarity that you have to make, you're just going to change that value out and do your calculation. So pretty easy for that. All right. So the way the way that this works is you are looking for what is getting absorbed. Okay. So what you see coming when you look at that solution is you see blue. What's happening with the wavelengths with that blue? It's getting reflected, right? So if you want to know the right value for absorbance, you've got to go on the opposite side of your color wheel. So if this is getting reflected, you want to try to find a light amount, a wavelength, okay, that is in the orange band. Does that make sense? You're trying to figure out what's getting absorbed, and that's going to be on the opposite side of the color wheel. You're looking then for a wavelength that's going to get absorbed. Your spectrophotometers will actually do this for you, and I'm going to take you through how to make that happen. But here you can see that this spot on this graph corresponds to the wavelength. It's about 625, it says. So 625 falls in this orange range right here. Does that make sense? The specs will take you through how to figure that out. But you need to understand the concept of how this is working. So you're looking for a wavelength, the wavelength that will best be absorbed. Okay? And they oftentimes will give you a graph like this and ask you, what wavelength would you want to use? You're going to find the highest peak. And then you're going to find where that corresponds. And then you can tell them, oh, I need this wavelength of light. Easy enough? All right. So this is what you're going to be doing. You are going to be creating an absorbance versus concentration graph. You're creating different concentrations. Yours won't be 8. It'll be less than that because you're starting out at 0.2 and going down. Okay. So this will be a fractional amount. But you can see here, and then you're going to be given your unknown. You're going to check and see what its absorbance is. And then let's say that its absorbance ended up being right here. You would just drop a line down, and then that would tell you what the concentration is. So you find where it falls on this, what do they call it, line?
Yeah, line graph.
Yeah, it's a line graph. So where it falls on the line, you find where your absorbance hits that. And then all you have to do is see what the... And for the Vernier, the Lab Pro, it's really nice because if you just take your cursor and put it right there on the line, you can look over here and it's going to tell you what the your X and Y values are. So it's pretty handy that way. So you can try to find exactly on the line where that's hitting, and then that'll tell you what your other value is. And I can show you how to do that if you need help with it. Now, what Beer-Lambert's law says is that you can figure out the absorbency if you multiply these three things together. Okay? The molar absorbency constant, that is going to be the slope of your line. The path length, which is usually 1 centimeter, and it is 1 centimeter for you, times the molarity, which you will know. Okay? If you know this guy and you know these two, then you can solve for C. That makes sense? So that's Beer-Lambert. Okay, like I said, you can do your absorbency. You're gonna have to calibrate your spec. Calibrating your spec is with a blank. That's just distilled water. Make sure you use the distilled water from the bottles. Okay. Based on this calibration graph, if the absorbance of the unknown concentration was 0.34, what would be the molarity? So you would just find 0.34 on here. So it's 525. Half of 25 is, so this would be 32.5. So it'd be just a touch above that. So find it on the line, drop down, so around like 375, something like that. Okay. I need to grab a couple things off the table here so I can show you a few things about these specs. All right. So this is what your spectrophotometer looks like. It's going to plug in on the side here, and then this gets plugged directly into the computer. You are not going to be putting this into a lab